All right, what's going on, guys? I got a little bit of a different video for you today. So, my brother gave me this piece of plastic. I honestly can't even remember what it's for, but basically, these two little bolts stripped out the threads and actually broke all the plastic apart. And he asked me if I'd be able to print him a replacement, and I said sure. And because it's cold, I'm not doing as much riding anymore. I don't really have any riding content to deliver, so I figured I would make a video kind of on my process for reverse engineering this little piece and printing it out. And all I'm going to use is these Harbor Freight calipers, which actually aren't too bad, by the way, and basic roller. I don't have any radius gauges, so they might be a little wonky, but I'm going to try to be as true to the original part as possible. So I'm kind of just going to show my process, how I get the measurements. I like starting on paper, and then we'll go from there. I will be using Autodesk Fusion 360 for this project. I learned all my stuff on SolidWorks. I'm a SolidWorks guy, but SolidWorks is expensive. Now that I'm done school, my license is going to expire soon, so I've been forcing myself to learn Fusion 360. So this will be a nice project for that. It'll be a nice opportunity to familiarize myself with the program a little bit more and get used to its little quirks. So I'm going to unscrew this and then show some of my basic measurements. All right, so I got this thing all apart. It's not very complex. This should be pretty straightforward. The only thing that might be a little tricky is I don't know the thickness of this perfectly. I don't really have a great way of measuring it, so I will probably just kind of guesstimate that at about maybe 3 millimeters or so. But overall, this thing's pretty simple. It's not very intricate, so I'm going to get a pen and paper, start doing some dimensions of some of the more critical parts, and then we'll get to work on Fusion 360. All right, so our basic sketch is done. The one thing I haven't done yet is these radius corners. Now, I don't have radius gauge on me, so what I'm probably gonna do is really roughly kind of eyeball it with the calipers. This isn't a critical dimension for this application, so I'm really not too worried about how accurate it is. All right, so a little note before I continue onwards. It's important to understand that the distance between, this hole and this edge, the center, is not as critical as the distance between this hole center and this hole center and this one, because this is a fixed bolt pattern. So when you're measuring things out like this, you could dimension in from all your sides, but realistically, for a good fit, when you go to bolt the replacement part together, I like to measure the center to center distance of these circles instead. All right, so here we are in Fusion 360. As I said before, I don't know this program too well yet, so I'll kind of be fumbling my way through it, but start by making a sketch. Go ahead, stick it on the front plane. So I'm going to start with that front view, and we'll keep it real simple. I like always starting with simple shapes. There we have our basic front profile. I'm going to save that round cut through here for the very end, and you'll see why. But let's just go ahead and extrude this. And this will be going, let's see, 2.275 inches. So that's our basic shape to start with. rounded corners. So the basic profile is done. All right, so we have the basic shape here, but we have the underside is basically, I guess you could call it hollow. So what I'm gonna do is use the shell feature, click on this bottom surface, and the wall thickness that I measured was about 0.155 inches. Boom. Hollows out the entire underside. So go ahead and click OK. And next up, I'm going to add our holes. Alright, so after stumbling my way through this, like, I absolutely cannot stand some of the quirks of this program, but here we are at the finish line. It's pretty darn close. The only thing left is the round cut in this face right here, and I'm gonna go ahead and add some fillets to make the printer's life a little bit easier. No. Okay, you know what? I'm just not going to do it. Whatever. I don't feel like playing with it. But this is it. This is the finished project. So these holes, I left as the size I measured them because I find that when I print things, the holes tend to be a little bit smaller. A little bit of shrinkage. Oh, I realized I forgot to do the countersinks. So I'll do that real quick and then we'll be done. 5 thousandths, whatever. So that's it. This is the finished product. I'm going to actually, I haven't 100% decided how I'm going to print this yet. I believe I'm going to print it, I don't know, but I'm going to export it as a STL. So I'll do this and then load up in our slicer. All right, so the print is underway. When we come back, there will either be a completed part or a pile of spaghetti, and I'm not sure which because I haven't leveled that bed in forever. But the sun is setting, so I got to squeeze a ride in tonight. I'm not gonna be able to do the trip I wanted to, but you know, this comes first. So I'm gonna go squeeze that ride in. 2 hours later, I'll come check on this, and hopefully it's not a mess. All right, so unfortunately, this was a failed print. As you can see, this overhang, yeah, that shouldn't exist at all. And look how weak that is. So a lot of that probably has to do with my print settings. The support material, the way that I had it set up, just probably wasn't great. What I think I'm going to do is end up printing it upside down tomorrow. I still don't understand why there was a overhang at all. There should have been no support material there. Yeah, it's a little confusing, but regardless, I could just flip it over. I think the odds of a successful print will be much higher that way. I'll have a lot less support material. Yeah, there's things that just don't make sense. Like, I don't understand why this hole is closed. That is super bizarre. So, yep, give it another go tomorrow. All right, so here's the printed part. I decided to flip it upside down. I had a failed print the first time when I did it this way, so figured forget it. Everything looks good. I'm gonna pop this off and then we'll do test fit. All right, so here's the finished part. I sanded the top real quick. It was rough from the support material, and it's really not finished all the way, but it's good enough for what it is. So now's the moment of truth. We'll see if it fits. All right, so here's the finished part. I sanded the top real quick. It was rough from the support material, and it's really not finished all the way, but it's good enough for what it is. So now's the moment of truth. We'll see if it fits. All right, guys, so here's the finished product. Really don't have any complaints. The hole spacing was all bang on. The only thing that was a little bit of a pain was the holes for these two bolts were both very small, so threading them was kind of a pain without actually tapping it, but I don't have to worry about them stripping out anytime soon. So overall, I'm really pleased with how this turned out, and just goes to show what you can do with some calipers in not a lot of time if you have the right software and a printer. So hopefully you learned something in this video, and if you want to see more, make sure to hit that subscribe button. See ya.